this. So here's the differential that I used. This should make sense to you now, right? This is the logistic differential equation. What I did is I divided both sides by that quantity and got K. And then I multiplied through by Y, and I got this. And I separated the dy and the dt. I got a common denominator, which is L, so I multiplied this y, top and bottom, by L. And that's why you see this. And since I'm dividing by a fraction, I can multiply by its reciprocal, and I get this. So I'm going to stop here. Is everybody okay with that? Okay. So when you have this type of situation, you can factor out a y. Now, anytime you have this, we have something in math called relatively prime fractions. And here's an example. Those are relatively prime fractions because the common denominator is always going to be the product of these two. Okay, does that make sense? All right. Now, if you notice, I'm going to get 4 plus 3 over 12, correct? That's the common denominator. This, when that happens, is always the sum of the denominators. So if I take a look, I have that in this case. They're going to be relatively prime. So the sum of these two will be L. Okay, and you can verify that by having 1 over y here plus 1 over L minus y here. I'd have L minus y plus y over this product. And notice you'll end up with L. Yes, sir?
I don't understand how it's like the fourth part. I guess you like said like
1, 2, 3, 4.
that part, how you get from the fourth to the fifth.
This is over 1, correct?
Yeah.
So I multiply this top and bottom by L.
Yeah.
And so what oh, that's a great question. So what I have is 1 divided by Ly minus y squared over L. So I multiply by the reciprocal. It's like if I have 1 divided by 2/3, that's the same as 1 divided by 2/3. It's the same as 1 times 3/2.
Okay.
Okay, does that help? Okay, good question. I'm glad you asked. So what I'm saying is once I get here, I can break it into 2 fractions. And again, we're going to come back to this and do something called integration by partial fractions. So it's, we'll need to know, we'll go over a number of these. So in fact, it's one of those comfort math things I do when I stress out at a meeting. I stop listening and I just do integrate by partial fractions. Just makes me feel good. All right. So, and I think you'll be okay with that. So I integrated this and I got this. And I hope after you've done a few problems already, you can see why this is negative, because this is a derivative and its derivative needs to be negative in here. So I multiply by negative both out in front of the integral and make this a -1. Does everybody understand what I mean by that?
How is it a 1 on top and not an L still?
Because of this situation right here. When I can take this product, this sum, and write it like this. Does that answer that? So if I had these 2 fractions, I could combine them like this, right? Which would become L over, since these are all equals, I can go here and go back.
Yeah, but why is it a 1 and not an L? Or, no, never mind, I get it now.
You got it now?
Yeah.
Okay. And so I integrated and got this. Are we okay with this part? And I integrated on this side. And then I just rewrote them in this form. So I multiplied this by a -1, I multiplied this by a -1, and I multiplied this by a -1, because in the answer I need k to be negative. Negative k to be. And then I could combine them is, since I have subtraction here, I can write it as a division problem. Okay, are we okay with that? That's just using, okay, I see people nodding, it makes me feel okay. So then I said, the absolute value of this is e to this power, and I said that e to the c I'm going to call b. So that's where the b comes from. And what did I do here? Oh, I think there's a y here. And this, so I just got rid of the absolute value symbol. And then, since I have y over y, I just said y over y is 1, so I said L over y minus y over y is 1. I write it like this. I add the 1 to the both sides, so now I got my plus that I didn't have yesterday. And then I said the reciprocal of that is this, and the reciprocal of this is that. Are we okay with that? And then I just multiply both sides by L and got this. And if you want a copy of this, I can give this to you. Okay. So that is it being correct. Okay. Again, you don't need to do this. You need to know this, and you need to know this. Okay? But you can solve that differential equation. Okay? Okay, so we're going to have 2 sets of notes today. One is on verifying solutions. All right, so verifying solutions simply is a method that derivatives can be used to verify the function is a solution to a given differential equation. So let's take a look at this particular one. Let's show that find a particular solution of y if we know that. So we're figuring out c, in other words, okay? So notice there isn't any y on this side, so I don't have to separate the variables. All I need to do is integrate e to the 2x minus 2x squared dx. And Alexis, do you want to do e to the 2x, or do you want to do 2x squared? Integrate that.
I'll do e to the 2x.
Okay, what is that?
1/2 e to the 2x.
Yeah, 1/2 e to the 2x. Now this is, I check, I know I'm going to get e to the 2x guaranteed. I need to take the derivative of 2x, which is 2, and the coefficient here is 1, and 1/2 times 2 is that 1. Perfect, okay? Who would you like to do this? Alicia. What's the I'll write the minus sign for you. What's the antiderivative of this?
2/3 x cubed.
X cubed plus c, correct? So now I'm told that when x is 0, y is 4, so I have 4 equals 1/2 e to the 0 minus 2/3 times 0, that's handy dandy, plus c. So Sierra, what is e to the 0?
1.
So I have 1/2 here, plus c. This is the same as 8/2. equals 1/2 plus C, would you agree with that? So C equals what? 7/2. So my particular solution is going to be y equals 1/2 e to the 2x minus 2/3 x cubed plus 7/2. Okay, is some of that coming back? All right, good. This problem is exactly the same. A curve has this slope at each point xy on the curve. What is an equation for this curve if it passes through 0, 4? Well, if this is the slope, I would have to take the antiderivative, correct? And plug in the points 0, 4. And it's going to be exactly the same as this. So there are two different ways of saying asking you to do the same work. Because this right here is my derivative. They're asking what the curve is. This is how you compute the slope. So you're going to take the antiderivative and plug in 0, 4. All right, let's take a look at this one. Lucy, what is this creature?
Wouldn't that be the
Second
second derivative?
derivative. Now notice they want to know what y is, correct? And they give you a few hints. They tell you when you put 1 into the first derivative, you get 7/6. That's what that means. And then when you put 1 into y, the function, you get 0. Okay? So to get to dy dx, the first derivative, I have to find the antiderivative of this. Would you agree? What's the antiderivative of 1 over x squared? I can give you a hint if you want.
Would it just be a negative 1 over x?
It's exactly correct, because that's x to the minus 1, all right? Plus, now we could multiply that out, right? Or we can take a look and say, all right, u equals 1 minus 2x, so du dx is equal to a -2, correct? So that means a -1/2 du is equal to dx. Would you agree with that? And then it would become a -1/2 integrate u to the second power du. Are you okay with what I put in the margin right here? Okay. So I'd get u to what power? Perfect. What would be my coefficient here?
Negative 1/6.
-1/6.
Or 6.
No, it'd be a -1/6, right? Because I gotta divide by 3 or multiply by a third. Okay. So I know that this is going to be a -1/6, 1 minus 2x parentheses to the third plus c. And I forgot to write plus c, and I'm thinking 6. And I should write this as a 6. Oh, I'm using the wrong pen. Just using it, I was so happy because things were working well. Okay, so now we can use this information right here to figure out this C. Okay, Walker, you okay with that?
Mm-hmm.
Okay, so I get 7/6 here. And when I plug in 1, I'll have a -1 plus, could have wrote minus here, -1/6 parentheses. When I plug 1 in here, I get -1 cubed plus c. Matthew, does it look like I did everything correctly here? So a -1 cubed is a -1. A -1 times a -1/6 is a +1/6. here's my plus C. This is a negative 6 over 6 equals 7/6. So do I get what do I get here? Do I get 2?
Yeah, I think so.
Does that look correct? Alright, so my derivative now is dy over dx is a negative 1 over x minus 1/6 of 1 minus 2x to the third power plus 2. Alright, Matthew, y equals, what's the antiderivative of this thing?
The natural log.
Negative, right?
Yeah, negative natural log.
Absolute value, right?
Yep.
Wait, how does it 2 if the 1/6 was positive on this?
Right here,
Yeah,
what's a negative 6/6 plus 1/6?
negative 5/6.
And then I'm gonna add 5/6 to both sides. What's 7/6 plus 5/6?
And negative 2/6.
Let's try it again. 7 plus 5.
Wait, but it's in 6.
Right? This is a negative 5/6,
Yeah,
and it's a negative 5/6 plus c. So I'm gonna add 5/6.
oh, okay.
You okay?
Yeah.
That happens, that happens. It happens to all of us, unfortunately. Alrighty. Walker, what do you think? Anything you wanna guess? Do you think this will be 1 minus 2x in here?
Yeah.
What do you think the power will be?
4.
4. The issue is what's this coefficient, correct? Right?
Mm-hmm.
So, in my head, I know that I'm gonna do this, correct?
Yeah.
So I know that du dx, I'm gonna draw a little borderline because we're thinking about this, right?
Yeah.
We know that that's going to be a negative 2, correct?
Oh, yeah. Yeah.
Right? So I have a negative 1/2 du is equal to dx, correct?
Mm-hmm.
Okay? So now I have a negative 1/2 here. I have a negative 1/6, correct?
Mm-hmm.
And I have u to the 4th, du. So that was my dx right here that I'm pointing my fingers with.
Mm-hmm.
That negative 1/6 is that negative 1/6 right here, correct?
Yeah.
And I have u to the 4th. Or excuse me, u to the 3rd. Sorry. U to the 3rd. So now I have 1/12 u to the 3rd du. I'm going to pause. You know, I'm trying to save myself some work, right? Because in a lot of ways I'm doing the same thing. I know I'm going to get this here, correct? The question is what's the coefficient going to be here?
Mm-hmm.
So I'm going to take this is going to become the 4, and I'm going to either divide by 4 or multiply by 1/4, correct?
Yeah.
So my coefficient becomes positive what?
148.
148, perfect. Plus, what's this going to become?
2x.
Perfect, plus c, correct?
Yeah.
All right, so now I'm told to put a 1 in for x and I get a 0. So if I have the natural log of 1, Walker, is that automatically 0?
Yeah.
Okay. So I'm not even going to write it down. Are you okay with that?
Mm-hmm.
So I got 1 over 48 times, this is going to be a negative 1 just like before, correct?
Yeah.
But to the 4th power. Are you okay with that?
Yeah.
Plus 2, are you okay with that?
Mm-hmm.
Plus C. So I get 2 and 1 over 48.
Wouldn't it be plus 0? If you're multiplying 2 by 0.
Oh, I thought you meant.
Say this again.
Wait,
I put a 1 in here.
Yeah.
What's 2 times 1?
I'm really lost. I'm sorry.
Okay, so this right here, 1 is x.
Okay.
Y is 0. So when I put a 1 in here, I get 2. Okay. Plus C. Negative, would you agree with that,
Mm-hmm.
Walker?
Yeah.
2 times 48 is 96.
Yeah.
So negative 97 over 48.
Yeah.
So y equals negative natural log of absolute value plus 1 over 48, 1 minus 2x to the 4th plus 2x minus 97 over 48. Again, I struggle with using room.
Can you zoom in?
Hmm?
Can you zoom in?
Is that big enough?
Oh, yeah.
I'm sorry about my printing, especially when it's.
No, it's fine, it's just,
I know we
it
did,
was
but
zoomed out,
like
you know, it's hard
half
to
the
see.
stuff
Yeah.
It's fine though.
Okay. All right, Jenna,
I can't.
derivative, can I move on or am I going too
That was
fast?
That was the unanimous.
Wait.
Missed that one.
Okay.
Okay.
2 and 1 over
Is that
48.
the one?
Wouldn't it be 99 over 48 and then you subtract over to the other side?
Don't you take 48 times 2
We're adding them.
Yeah, but there's
and
another
then add the 1?
Yeah.
Did you
Okay,
forget
I
the
just
plus
can't-
sign?
No.
What?
Did you forget the plus sign?
No, I just was confused.
I got plus C right here.
Never mind.
I think I'm confused now.
2 and 1/48, when you say 2, when you write a mixed number, you
Oh,
guys
it's a
know it's
mixed number?
addition.
Yeah.
Oh, I didn't know it was a mix up, okay.
Oh, I know why you guys didn't work at Kruger Welding. Did you? I bet you guys weren't born in the 60s, 70s, or 80s.
No.
Am I right?
Yeah, you're
Oh, I
right.
keep forgetting that. Like, we would have to measure 2.5 inches
No, I know what a mixed
and know
number
it's
is.
2 plus a half an inch.
I know what it is, I just thought you messed up.
Okay. See, I had to know that stuff when I was 9. This is my dad had several
It
favorite
just looks
quotes.
weird in writing because we are not.
Yeah, we
don't
never
use mixed
use mixed
numbers.
numbers.
I know we don't use
He's
mixed
only
numbers.
So then why'd you use a mixed number?
Well,
It's good. Yeah, I don't know.
okay, I will put the plus sign there.
Thanks.
I
Appreciate
always
it.
use mixed numbers too.
Why do it? Because
No, there's just so much of a
this is what
space.
happens, Sarah. Sometimes I'm old school, so sometimes I throw myself back into the 60s.
There's just such a big space between them.
I know. Can I go on now or not?
Oh, yeah.
Okay. I know, I love these discussions, that's why I come every day. All right. Jenna, what's the derivative of sine?
Cosine.
Perfect. What's the derivative of cosine?
Negative sign.
Perfect. Okay. What's the antiderivative of sine?
Negative cosine.
Plus c, right?
Plus C.
Okay. What's the antiderivative of cosine?
Sine plus C.
You know what? I got so many wrong because of this right here. It took me, Walker, I bet it took me weeks to get a handle of that. The signs. I was always putting the wrong sign on the wrong sign, or
Tricky.
cosine. And then, this is called sine and not sin, and then you put signs on signs.
It's ridiculous.
It's nuts.
Crazy.
Okay, for what value of k will y equal k e to the negative 4x minus 2 sine of 5x be a solution to the differential equation? Oh my gosh, what are we gonna do here?
That was scary.
I have no idea.
Well, this is.
Well, I do. Okay, because I've done this problem. All right, Ethan, what does that baby mean?
Y.
What's on all those two little tick marks? Can you see them?
2 prime.
Okay, what does 2 prime mean?
This,
Like 13 and 19, I got 2 primes? That add up to 32, that start with a 3?
Yeah.
No,
Second derivative.
second derivative. So I need the second derivative, right? Because I got this function here?
Yeah.
Okay, so what's the first derivative? Or what we call 1 prime. 1 prime, I should say. So what's the derivative of that be?
1, negative 1/5.
No, you're doing the antiderivative. Don't be doing that. Take the derivative.
Negative 4.
Don't hit that garage door. Does that joke still resonate or not?
Yeah, it totally does.
Okay. So you know you're gonna get this, correct?
Yeah.
E to the negative 4x. By the way, this k is a constant, right? Everybody understand that? If it's not e or excuse me, if it's not x or y, it's a constant. So you gotta take one, but you gotta do the chain rule, correct?
Yeah.
So that'll give you what? What's the derivative of negative 4x?
Negative 4.
So do you see where I get negative 4k?
Yeah.
All right, so Jenna said the derivative of sine is cosine, correct?
Yeah.
But I got this 5x here that I gotta take the derivative of,
Yeah.
right? The chain rule, we're reviewing the chain rule, correct? And that derivative is what?
5.
And so that's gonna be multiplying,
9,
so that's gonna be
2.
10. Perfect. Okay? Okay, that's the first derivative. Now we're gonna do the second derivative. I know I'm gonna get e to the negative 4x, right?
Yeah.
So this negative 4k becomes what?
16k.
Perfect. Now, Jenna told us that the derivative of cosine is negative sine, right? So are you okay that I make this a plus?
Yeah.
Are you okay that I make this a sine of 5x? Now notice the way I do that. I try to put an appropriate gap, and I struggle with that, okay? Because I know this 10 is gonna change.
Yeah.
It's gonna become a what?
50.
50. Okay? Now, I've got y. I got y double prime.
Yeah.
Or what you say 2 prime. Which I thought was cute. And guess what, Ethan? It's okay to be cute. My mother-in-law thought I was cute. Because I was the only funny son-in-law. Okay, here's the thing. And this will be on the tube. You know, the YouTube. Okay. My mother-in-law, she lived to almost make it to 94, but she started gradually going down, right? And she's diabetic. But the only thing she wants to eat are food that are like Twinkies, okay? Ice cream, cheese curds, onion rings, okay? Back when she was 70, 80, not appropriate food, right? But her diabetes is going nuts. Why? Because she's aging and she's getting closer to what I call the transition, okay? And so, you know, her sons and daughters want her to live forever. And I said, Rita, that was her name. Rita, what makes you happy? She said, onion rings. I said, eat onion rings. Okay? So every time she eats something, I would say, Rita, does it make you feel happy? And she said, yes. And then she said, you know what? You're really cute. And this is when I had braces on. It isn't how you look. It's how you make people feel that makes you cute. I decided. Okay? So thank you for saying 2 prime. Okay? That's what made me think of that. Alright? And you guys didn't think calculus had anything to do with life. Alrighty, so we're gonna plug this baby in. We got 16k e to the negative 4x plus 50 sine of 5x. So this is this baby right here. Plus 25 parentheses. K e to the negative 4x minus 2 sine of 5x, parenthesis, parenthesis, equals negative 82 e to the negative 4x. My gosh, it's long. I can't believe I didn't fall off the page. All right, what do I get here? Move a little bit to the left. 16k e to the negative 4x plus 50 sine of 5x plus 25k e to the negative 4x minus, oh, I am so happy, Walker, you're gonna find out why.
Oh, I see it.
50 sine of the 5x parentheses equals a negative 82 e to the negative 4x. You know why I'm happy, Walker? I am so tired of writing all that stuff that I'm really going to be happy going like this. Kabam, kabam, right? So, what can I get here? Ooh, I have 16k and 25k e to the negative 4x. Walker, what's 16k plus 25k?
41k?
Is he right, Ethan?
Yeah.
I wrote E too many times, but I have an eraser.
Wow, that probably worked out so cute.
Ethan, remember I want to figure out K. Can you?
Yeah, no way.
Can you?
Wow. Yeah,
How?
but each side of 41 each.
What do you get if I do that? So you're saying divide by this
Oh,
for all of our fans out in Ibis land. Oops. Right?
yeah.
Can you do that in your head? What is it?
Negative 82 over 41.
What is a negative 82 over 41? I agree with you 100%. How many times does 4 go into 8?
Bitch.
What?
2.
Negative 2?
Don't even laugh.
She's struck out a lot.
It would only be better if the answer was 3, correct?
That was a key problem.
There's not a 3 on this note sheet. Oh no, there isn't.
There was over here.
First problem. There's 3 with the first problem.
There's a couple of 3s here. I'm really working at them. So,
It's a missed opportunity.
That was an amazing.
So-
like, so satisfying.
I'm going to give you one more sheet of notes. Can you
I
guys
was gonna
handle it?
cross out the 50
Okay,
cents.
can you handle it? You doing
And then
okay
just
on that?
Like all that, and I thought we were gonna get some bonkers answer, and it was like, it's so silly.
So, okay,
Negative.
okay, actually, Brant, I didn't hear anything you say, but I find that really satisfying when everything just dies and you end up. with-
That's what I said. I said I thought it was gonna be like bonkers, and then it was like so cute at the end.
Yeah, yeah, it is. You know, like I said, it would've been, I'm gonna have to rewrite the problem so we end up with 3s. Let's see if this is right.
Like, what does that apply?
No, like how do you get your answer to be so perfect? You know what I'm saying? Like, who
Go in,
writes these
go in
problems?
reverse.
Oh, you were worried, weren't you?
Oh, I was
Yeah.
real worried.
I thought it was gonna be like something fraction, like 97 over 1.
I was so scared.
But you see how in this class review, how do you take e to the x? How do you take, we're going back derivative and integral kind of back and forth?
Are you
That's kind of how we review it.
You're like turning around so slow.
One.
I couldn't find that. Is it a good pass?
Oh, I heard that.
Mediocre crack. If it's like, yeah.
I don't,
And I'm trying to give you some ample time to get some stuff done in this class. That's kind of the way this class works. Doesn't perfect like this.
I hope so.
Alrighty, so
Did you see the new one?
let's look at this. This is a differential equation because it's a derivative. Here's the slow field. So if you take a look like where x is equal to 0, you would have little horizontal lines like this. Where x is equal to a half, you would have right here slopes. That would be 1. Here you would be 1. You'd have slopes that are 2. And you can see that the slopes are increasing. Over on this side, your slopes are negative. Would you agree with that? The other thing I want you to notice is when it's in terms of x, they are parallel vertically. And it kind of makes sense because as we go vertically, this is x equals 1. And so going up and down, x never changes. So all of them will have a slope of 2. All of them here will have a slope of a negative 2. So I use that, if it's in terms of x, it should look like this. Because you got to say, okay, on the AP test, they're going to give you a differential equation. They're going to say, which one of these graphs is this differential equation? Well, if it's in terms of x, I look up and down to see if they're parallel. Does that kind of make sense to everybody? Likewise, if they're in terms of y is going to be the same as you go left and right, so they'll be parallel horizontally. Okay, did I explain that all? Okay? All right, so if I solve this, here I would get y equals x squared plus c. And if you can take a look, you have different parabolas that go, here's my c is 1. So I'd have a parabola like that. Okay? Or if I go down here. And they don't have to be perfect. They're looking to see, hey, do you realize that that's kind of the way the grain goes? My dad was into grain. He was a woodworker. And he said 2 things. First of all, never go across the grain when you're sanding. And secondly, when you're cutting up a turkey or cutting up a piece of meat, don't cut against the grain. Cut with the grain. You'll get a lot better piece of meat if you do that, okay? So right here, here's a differential equation. And it has some spots. So right here, I'm going to take a look. This is a product. So here are some points. So I said this point is 1, 2. So if I multiply that, I'm going to have a slope of 2. Here I'm going to have a slope of 1. So I always think the slope of 1 kind of goes at a 45-degree angle. Here I'm going to have a slope of a negative 1. Here I'll have a slope of a negative 2. And all I have to show is that this is a little bit more slanty than this. This is a little bit more slanty. This is going to be a slope of 2 again. And then this is going to be a slope of 3. Or excuse me, 4. I can't multiply. Here's a slant, negative 4. Here's a negative 2. This is 1. This is 2. This is 2. This is 4. Oh, I got these ones right here. You can't see them. 0, 0, 0, 0. Negative 1, negative 2, negative 2, negative 4. Kind of makes sense? Sometimes what I do is I create a little table. So here I have x, I would have y, right here I have dy dx. And so I came up with some numbers, and what I did, I said, okay, x is a negative 1. And I said, what would my values for a negative 1 be? I'd be 2, 1, 0, negative 1, negative 2. And I know I'm multiplying by a negative 1. So, or excuse me, I'm multiplying by a negative 2. So, right here I would have 2, if y is 2, I'd have 2 plus 2, which was 4. Here I would have 1 plus 2, which is 3. Here I'd have 0 plus 2, which is 2. And then I'd have 1 and I'd have 0. And then I do this. So right down here I have 0. Here I have 1. Here I have 3. Here I have 2. Yeah, 1 I would have 3. And right here I would have 4. And then I did the same thing. I said, all right, what if I have 0? So then it's going to be 0 the entire time. And so it's going to be 2 minus 0, 1 minus 0, 0 minus 0, negative 1 minus 0, negative 2 minus 0. And so this was 0. This would be 1. This would be 2. This would be negative 1. And this would be negative 2. Does that make sense, everybody? And then my next number, I said, okay, I had 1. So, excuse me. So right here I would have y would be 0, and I'd have a negative 2. Here I had a negative 1. Here I would have 0. Because you'd have 2 minus 2. So here I'd have a negative 1 minus 2 would be a negative 3. And this would be a negative 4, almost vertical. And then I made x2, so that's going to be a minus 4. And I ended up getting a lot of negatives here. So I just kept them like that. Right here, the figure below shows the slope of the differential equation, so this is kind of crazy. Let f be a function that satisfies the given differential. Write an equation for the tangent line to the curve at y equals f of x through the point. So, Alexa, equation for a tangent line. What 2 things do I need?
Alexis Kruger.
Alexis. Did I call you Alexa again?
Yes.
Can I just do this?
No.
Or do you want to do it?
It's fine.
Alexa. Alexis. Alexis, what 2 things do you need for equation of a tangent line?
The slope, which would be the derivative of the original line.
Oh, okay. So here's my slope,
And a point.
and the point is right here. It even tells me point, correct? So what do I get for a slope here? 1 minus what?
X
Yeah, what is X?
So -1 times -2.
And what is negative one times negative
2.
two? And so what's my slope?
-1.
And so the equation of my tangent line is?
-1.
And just write negative?
Yep.
X is in here,
Plus.
plus
1 -2.
minus two. And I always check, if I put -1 in here, I get 0, and 0 minus 2 is a -2. I always check because I just get kind of nervous about that. Now, if I take a look at this, -1, -2, I believe, is this point right here.
It sounds great.
How's that work? That better?
Yes.
Okay. And so that graph looks like it comes this way. And it looks like it's gonna cross the x-axis and head over here. And if I follow the green this way, it looks like it's headed there. And my tangent line looks something like that. All right, backside. You have something that looks like this? All right, so let's look at this. Are they parallel vertically? Or do they change? Like, is this slope the same as this slope?
No.
Is this slope the same as this slope? No. So it means it can't be A and it can't be that, because it is not parallel vertically. So when I do these, one thing, I eliminate the ones that I think, so at least I can get rid of some. Is that making sense? All right. Are they parallel horizontally? Is, look at this one. Is it the same as this one? Is this one the same as this one? It's not, is it? So that means I can get rid of this one. Not parallel. And the reason I'm writing this down here horizontally is when you take a look at your notes, you'll say, why did Kruger cross those out? That's why I crossed them out. Now I got a 50-50 chance, correct? So I take a look, if I look at this, I can put some values in here. So let's look at a point, let's take a look at this point, 1, 1. So if I put 1, 1, I would get 2 here, and I get a 1 here, correct? Not very helpful. If I go over here, it is a -1, 1, and I would get a -1 here, I'd get 0 here, correct? I'll say it again. So I'm picking some easy numbers. 1 and -1, 1 is the easiest. And then these are pretty good, the opposites. So it's got to be C, correct? Because it has a slope of 0. So what I've written this down as a note, not equal to 0. Everybody okay with that? All right. I am done talking, because I'm messing up already enough.